A gas bubble formed from an explosion under water oscillates with a certain time period. The period T is proportional to pressure raised to A and the density of water raised to B, the energy of explosion raised to C. We need to find the values of A, B, and C. Now, as per the dimensional analysis, the dimensions of physical quantities on either side of the equation must match. So, if we start by writing the dimensions of the quantities, the dimensions of time is simply T. The pressure can be written as force per unit area. So we know force is mass into acceleration, where acceleration is change in length over time. But since we are only looking at dimensions, we can write the change in velocity as velocity over time, and we have area. So the dimensions of pressure will be mass, and then velocity is distance over time. So L over T, there is time in the denominator already, so we have T square, and then area, and so this will be mass by, and then a length in the numerator we can ignore, so length into T square. Now density, we know it is mass per unit volume. So the dimensions of density will be mass by L cube. So M over L cube. Now, when it comes to energy, we know that it is work done by a force, which is basically force times the displacement. So, when we obtained the dimensions of the pressure, I think we anyway, in a way, we have the dimensions of the force here. So, if you get this quantity, so we can use that. So here, if I look at the force, so the dimensions of energy will be, so if I borrow the dimensions of force here, we get L by T square, and then we have displacement, so we multiply by L. So we get M L square over T square. Now, if we equate the dimensions of the quantities on either side, left hand side we have time dimension, and on the right hand side we have pressure raised to A. So this would be M over L T square, and then this is raised to A, so this is equal to, and then we have a density that is raised to B, M by L cube raised to B. And then we have energy ml square by T square, so M L square by T square, and then this is raised to C. Okay, on the right hand side we don't have mass and length dimensions, so we can write them as m to the power 0, L to the power 0, and T to the power 1. And on the right hand side, if we group the mass dimensions together, we get m to the power A plus B plus C, and for the length dimensions have minus A here, and then this is 3 in the denominator, so if it goes upstairs, that's minus 3B and then plus 2C. And the time dimensions, we have minus 2A and then minus 2C. If I equate the dimensions of mass, I should get A plus B plus C as 0. And if I do the same thing for length, I should get minus A minus 3B plus 2c is. Now take a look at the dimensions of the time. So we get minus 2a minus 2c equal to 1. Now from the first two equations, if I need to eliminate b, I just have to multiply the first equation with b and then add it to the second equation. So we get 3 minus 1, so that's 2a, then b disappears, then I have 5c, that is 0. Now if I use this equation with the third equation that we have here, if I simply add them, you see that what do we have? 3c is 1, so c is 1 over. And then if I substitute in the third equation, so I have 2a as minus 2c minus 1. So we put the values here, so this is by 3 minus 1, so that is minus 5 by 3. So a comes out to be minus 5 by 6. So now all we have to do is take these values and then substitute in the first equation, and then we will get the value of b. So b is minus a, so that's 5 by 6, and then minus c. So this is 3. I think this is 1 by